Today we're learning about gravity and the gravitational constant. But first, I have a question for you. So, if the moon and the Earth were closer to one another, would we weigh more than we do right now? I want you to explain your thinking. Type your answer up inside this text box and let me know how you came up with your answer. Alright, so here is a man on the moon, and you are going to look at this picture very closely and write down two things that you notice. We'll try it again with this image of the moon orbiting the Earth. Write down two things that you notice. And of course, we should be relating these things to gravity. Now let's try one last image. Write down two things that you observe related to gravity in this picture. So, what did you observe? So, go ahead and finish that up, and then make sure that you have your worksheet open so that we can talk about gravity. You can fill in the blanks anytime you see a word or phrase with a red color. That is the word or phrase that you need to fill in the blank on your worksheet that corresponds with the sentence that we're talking about here in the slides deck. So now that we're thinking about gravity and how we, thanks to those three images, let's think a minute about force. You actually exert an attractive force on everything around you, and likewise, everything around you exerts an equal attractive force on you. And this is a force that we call gravity, and specifically it's an attractive force. So as we learn about gravity, we're going to find that anything that has mass is attracted by the force of gravity. We call this the law of gravitation, and the law of gravitation states that any two masses exert an attractive force on each other. We can actually solve for force or determine force by using a mathematical formula, and that's what we see here, which states that force equals the universal gravitational constant times the mass of the first object times the mass of the second object, all divided by the distance between the two objects squared. The constant in this formula is the universal gravitational constant, which is represented by the capital letter G, and that always equals 6.673 times 10 to the negative 11th, which means it's an extremely tiny number, many decimal places out. The letters in this formula, the F's and the G's and the M's and the D's, all stand for something, and here's what they stand for. F equals the force of gravity between the two objects, which is what we're trying to solve for with this formula. Then we have G, which I just told you was the universal gravitational force, or what we call the universal gravitational constant, another name for it. It's represented by the capital letter G. Then a small case m with a little 1 represents the mass of the first object, and then the small letter m with the 2 represents the mass of the second object. Now it doesn't matter which object is the first object or which object is the second object, because you're simply multiplying them together, so order of operations wouldn't come into play, so you could have either one come before the other. Doesn't really matter. But then we have the letter D, capital letter D, which stands for the distance that separates the two objects. And this isn't the perimeter of the objects that we would measure. We would measure the very dead center of each object. That would be the distance squared that we would divide everything by in order to finally solve for F, which is again the force of gravity between those two objects. So the gravitation force depends on two things. They are mass of the two objects and the distance between the two objects. Here's a question to ponder. Why do you think the Earth exerts a force on you that you can feel, your weight, but you can't feel the force the desk that you're sitting at is exerting on you? Deep thoughts to ponder.